All right, so now I'm going to prove this formula. This formula is correct, provided that n is a natural number and x is not equal to 1. All right, so the proof revolves around revolves around a computation. And an example of that computation was given in the previous video. All right, so I guess I should state my assumptions, right? Okay, assume x is not 1. All right, so now we'll multiply using the distributive property. 1 plus x squared plus, let's see, x cubed. Now I'm going to actually put in, let's see, I guess I have x to the n minus 1 there. X to the n minus 1. I'm going to put in the thing that came before that. So what comes before n minus 1 is n minus 2. Right, if here you're at n minus 1, then if you subtract 1, then yeah, okay. All right, so we multiply these together, doing very similar to what we did before, but with a finite, I guess this is still finite, but we're being very general here. Okay, so it's like a general computation. Okay, so distributive property, first with the x, you get x plus x squared plus x cubed plus x to the 4th plus, and you just keep doing that. Okay, now x times x to the n plus 2. I'll just put that here like this. N minus 2. And then I'll use the fact that I can erase so easily. So, okay. Now remember, same base, you add the exponents, right? So if you're adding the exponents here, then this will become x to the n minus 2 plus 1, right? Which is x, let's see, negative 2 plus 1 would be x to the n minus 1. And this one right here, this is the same base, you add the exponents. So you can say 1 plus n minus 1 or n minus 1 plus 1. And then negatives cancel, you get x to the n. Okay, so but because I have this handy little eraser here, I can just do this. And x to the n there. Okay, and so that's only half of the distributive, right? This was the part where we did this times each of these, and so on, like we did before. Now we'll do negative 1 times each of these throughout. Okay, so then we've got minus 1 minus x squared minus x cubed. Notice that this is where the issue always lies with this, right? Notice there's actually an x to the 4th right there, so because that's the thing that came after x cubed, so we'd have minus x to the 4th minus, oh, of course, okay, so we get minus x to the n minus 2 minus x to the n minus 1 there. All right, and so now we're going to get a bunch of things to cancel. These will cancel there, those will all cancel. And so like right here as well, there's going to be there's going to be an x to the n minus 2 that'll cancel with that thing. Those will cancel like that. And we're left with x to the n minus 1. Okay, so what have we just done here, right? We've just shown that this equals x to the n minus 1. All right. Now, since x is not equal to 1, we can divide by it. We can divide by x minus 1. Right, see, if x was equal to 1, dividing by x minus 1 would be dividing by 0, which we can't do, right? So dividing both sides by x minus 1, we get the result. Okay, and that's basically it. Maybe you don't quite see that. So let me just draw that in real fast so you can see what I'm doing. Plus x to the n minus 1. This is equal to x to the n minus 1. All right, so through all those computations, that's what we did. We got to where we found that was, through all those computations, we found that, right? Since x is not equal to 1, we can divide both sides by x minus 1. And then those will cancel, and then we get exactly what we wanted, which was the formula. Okay, so that's how the formula is proved. It's really just the distributive property and divide both sides by x minus 1.